Thank you, thank you. Thanks everyone. Again, my name is Daniel Ingevaldson. I'm the CTO of Easy Solutions. And we're going to talk today about the Easy Solutions Total Fraud Protection Platform. So before we go into the actual demo, I want to walk you through a little bit about what we do. We're kind of in the bad guy business. We've spent our whole careers tracking bad guys, understanding threats, understanding how attacks manifest in our customer population. Now, the chart that I show here, just one image, gives you kind of a representation of what we do. Everything we do is wrapped in threat intelligence or fraud intelligence. We're always trying to understand what's happening out there, from understanding phishing attacks, understanding malware attacks, taking them down, to actually tracking black market activity when guys are selling credit card numbers for our banks. We also deliver safe browsing technology, both in mobile and e-banking, to protect the actual devices from fraud. And then up the stack, we move into authentication and transaction monitoring. Now today, we're going to show a demo here, and hopefully I can get all the switching back and forth. I'm going from my actual Mac to my iPhone to demonstrate a new concept that we call Trusted Mobile. And basically, what we want to do here is show you all these different layers interplaying together to do one specific application that I'll show, one actual technology application. So let's go into this. So right here on this screen, you simply see a sample e-banking or home banking environment that we've constructed. Looks very much like any one that you would have seen. And let me switch over to my phone really quickly, see if that's right. Okay, so this is a sample mobile banking application that we've constructed as well. And we're going to demonstrate a couple functions here around a technology called push authentication, and as well as how that integrates with our back end. So let me log in to the bank, and nothing out of the ordinary so far. Simply log in as you normally would. And then right here, what you see here is the indication that the back-end authentication system is sending an external out-of-band authentication to the smartphone. Now, push authentication is kind of the next step beyond out-of-band SMS-based authentication. This is basically a push to the phone, and then I can simply authorize that I can actually authorize the authentication by clicking a single button. So instead of actually entering or copying and pasting an SMS code, you simply click one button on your phone, which is already tied to an account, to give really a better out-of-band experience. I'm not a big fan of the SMS out-of-band. A lot of customers aren't. There's a monetary cost associated with each transaction. This is actually built into the application itself. So let me kind of go a step further. So this is, again, a sample transaction, a sample balance sheet within a consumer banking environment. Now, I want to transfer some money. So I'll just show a simple transfer between two fake accounts, and I'll do what's considered a low-risk transaction of $100. So you see right here, this is considered a medium-risk transaction because this transaction is running through our anomaly detection system on the back end. Part of our stack is actually doing real-time risk qualification for all transactions. So this is a medium-risk or low-risk transaction. We can confirm that, no problem. Now, what if I want to do a high-risk transaction? So the same two accounts, one to the other, and we have an account rule set up for this account based on the behavior of the account. This is considered a high-risk transaction. So the application is asking me to authenticate once more. And again, Detect ID is moving in to actually handle the request to the phone. So switching back to my handheld device, now we have a push authentication alert that comes to the phone that basically tells the customer or requests the customer to authenticate that actual transaction. So it's kind of a closed-loop system. If the bank has a trusted relationship with that device, you can use that device in a much more customer-friendly way to simply notify the end user of the transaction or actually have them accept it. So if I click Accept, the transaction goes through, and I can switch back to the mobile banking app, and there you see that the transaction has been processed. So what else is going on behind the scenes? So if you go back to this, you've got transaction monitoring doing real-time scoring of all the transactions. You have the authentication layer, which is doing the push authentication to my phone. You can also handle 10 or 15 other sorts of authentication factors, from tokens, challenge questions, typical multi-factor authentication system. But also, my handheld device has integrated technology in the safe browsing layer. So we believe that in order to trust a handheld device, you have to protect it from all the threats that are out there. A lot of discussions about mobile malware, a lot of discussions about malware which is intercepting SMS messages to basically defeat out-of-band technology. So you can't really see it in the demo, but I'll show you really as much as I can behind the scenes. So Going back to, let me switch one more time, going back to the mobile application, we've embedded 3 or 4 SDKs from our Trusted Mobile Toolkit to protect this device. So we're actually monitoring for fake applications, we're monitoring for actual jailbreak status of that device, if it's jailbroken, if all the security technology has been disabled. And on the Android platform, we're looking for malware. There's been 250,000 mobile malware samples already detected on the Android platform. The Android platform is unfortunately much less secure than the iOS platform. So let me show you where all this data goes. I'll switch back to my PC once more. Here in this view, what you see is the data that is available from the SDK. So all these end-user devices are constantly reporting data to our cloud in the threat intelligence layer. So this chart shows usage stats for mobile devices. And I'll show you kind of the type of data that comes in. So let me minimize some of these so I can actually click into the events associated with my device. So these are iOS-related hits that are coming in for daily usage, and you see there's malware events, farming events, phishing events. So if I click this one, there's a slight delay from the Wi-Fi, but you'll see the actual metadata coming off the phone. So we're collecting unique device identifiers, we're collecting the OS, we're collecting, again, if it's a jailbroken phone. There's a big difference between the security of an Android 4.4 version or an Android 2.2 version. Google just released a brand new version out there that does a lot of new anti-malware protection, but literally no one runs it. So we have customers that are asking us specifically, just tell us if phones are jailbroken, because we want to deal with those phones differently in a different sort of environment. We want to limit their actual functionality, maybe arbitrarily limit ACH transfers from those accounts because they're potentially more insecure. So kind of in closing, the point and everything we try to do at EasySol is we try to provide a truly integrated, layered solution. We consider Total Fraud Protection as being an end-to-end platform to go from threat intelligence, external account takeover inputs into the fraud cycle, all the way through to caching. We basically look at the whole problem as kind of the fraud life cycle: attack setup, attack launch, and caching. If we can use these different layers to map against each one of those phases of the fraud life cycle, we can stop it in the beginning or we can stop it in the end. And this demo was kind of designed to show some integration between really all 4 of these layers to provide a truly integrated solution. And with 30 seconds left, that's the end of the demo. Thank you.